Hello students, I'm Dr. Austin and this is a little video for Chemistry 111, General Chemistry. I wanted to overview the textbook, a great resource for you, and work a couple of problems. All right, so a couple of things. We do have a textbook. Before we get there, I just want to talk about a couple of things. We mentioned this in class. Many of you are not chemistry majors and you may not have a strong interest in chemistry or maybe a strong aptitude. Maybe your background wasn't so great. But you should take the approach that I'm not good at chemistry yet. Sometimes we can have a fixed mindset and we might think, you have to be smart in chemistry or math or something along those lines. And, you might say, hey, I'm not smart, so I can't get it. And that's a mindset that many people have. However, research has shown that if we have a growth mindset, that is, you can develop intelligence, you can develop skills in academic areas like chemistry and math, that you can actually improve, you can grow with it. And if any of you have ever been in the band, in a play, on a sports team, you all know that, again, a little bit of practice goes a long way, particularly if it's a little bit of practice every day or, several days a week over several weeks, you can actually really improve. So one of the ways that we can improve and, think about, hey, I'm not good at chemistry yet, but I can get better, is the study cycle. So again, it starts where you maybe before class, you would read the material. I had the sections in the textbook. You could read it or at least preview it, maybe do some outlines, look at some of the bold words. Certainly come to class. As you've seen, we do some small teamworks. We'll do some problems. Then after class, you want to review the notes, make sure you fill in the gaps, think about questions, and then study. And again, studying can happen multiple times a week, and you can set a specific goal. Maybe it's to learn over a couple of sections of the textbook, or maybe to work on homework one, and then you study. Again, 30 to 50 minutes or so, not forever, but do a 30 to 50 minutes, think about it, work problems, go over notes, work problems in the textbooks. I'm going to show you that. Then, make sure you take a 5 to 10 minute break, clear your mind, get a drink of water, walk around, and then summarize, wrap up mentally. Did you get this section? What questions do you still have? And then you might continue studying. And sometimes, I get 50 minutes in, working on a project, and I'm like, I'm just getting started. I need some more time. Other times I'm a little tired, maybe something else to do, and you go on. And then again, you want to, after the studying, check and to see if you're effective. You might need to ask a friend or maybe ask your instructor. All right, so this is a good way. Now, in order for the studying to happen, one of the good ways that you can study well is using this guy, your textbook. Big textbook, kind of big, kind of heavy. This is the physical version, right? The 2E that we've talked about. You may have the online version, and they're really the same, have the same content, slight differences here and there. So again, a couple of things as we point out. Again, chapter 1, again, starts out, has some general information, and you've seen some of these figures before. Not all of them, but a couple of them I've used in class. And so it has some figures, some text, some things to look at, some ways. We actually use this exact figure in our activity to think about how we classify matter. So that's helpful. Again, we talked about this figure in terms of water being broken down into various substances. Right? A little bit of information about physical, chemical changes that are taking place. Again, we have the periodic table, which is going to be important for us. We also did exactly this table of prefixes, that prefix, and also this table of base units right here in class. And we need to memorize those. So that's a good resource right here in your textbook, and of course also in your handouts. And then this guy right here, this example 1.1. Throughout the chapters, there's a problem, then they actually show you a solution, it's worked out, and then there are a couple of places to check for your learning with the answers. So these, they give you the problem, the answer's down here, but they don't show you the work in between. All right, but based on this work up here, they're hoping that you can get that. All right, so again, lots of ways to use this textbook effectively. One of those ways is to work on some problems. So at the back of each chapter, there are exercises that you can work over. And let's just try one or two of these quick here and take a look at them. And so let's first of all, I've just picked out number 29 for us to talk about. It says a volume of a sample oxygen gas changed from 10 milliliters to 11 milliliters as the temperature changed. Is this a chemical or physical change? right? So you might say, well, I'm having a little struggle with that. Well, we can go back here in the chapter and find information about this. And if you flip around, you're like, hey, oh, here we go. And so we have some information. And so in this particular figure, they're showing you some physical changes, and this one's some wax, like in a candle. When it starts to heat up, the wax melts. That would be an example of physical change, that the wax itself is just going from a more solid to more liquid. Same thing in cooking. Water, we heat it up, and we can actually condense it and go from liquid water into steam. So those are a couple of examples of physical changes. Chemical changes would be copper and nitric acid reacting, a match burning, cooking food, and particularly like as you change the composition of myoglobin, and that goes from sort of the red to brown. And then you've all probably experienced an apple or banana ripening and turning brown or changing. And those are examples of chemical changes. And that is, we've actually changed substances, right? So the copper and the nitric acid are reacting. The wood is actually burning in the presence of oxygen that forms CO2 and water. So then we come back here and we say, hey, we are thinking about this problem. The volume of oxygen changing as the temperature change. Is that chemical or physical? So you might think about it, that your answer. But to confirm it, you might say, well, hey, I'm just learning chemistry. How do I know? Well, the nice thing is in the back of the textbook, and this is whether it's online or physical, there's an answer key in the back, and this is for chapter 1. Contains many, looks like in this case, it's mostly the odd numbers. And then we get down to question 29, and oh, right there we go. We have a physical change. Let's try one more problem. So go back to chapter 1. Let's work on question 77. And this one's working with conversions. And so let's drop down here. We're going to do F. We're going to determine the mass of a bushel of rye, 32 pounds, and we're going to convert that into kilograms. All right, so let's get our needed information here. And again, key thing is here, we're going to need to go from pounds into kilograms. And specifically, we're going to have 32.0 pounds. We use our unit conversion factor method. So we need something here and here to make sure this occurs. And so now, but the key thing is, we really need to find a conversion factor. We don't have to memorize these, but we need to be able to find them and then use them. On an exam or something like that, there'll be a table of such conversion factors. In the textbook, we can actually find them. And in this textbook, again, we see that we have some for length, we have some for volume, and then also over here for mass. And then we have this 1 kilogram is equal to 2.2046 pounds. Sure, write that down. And so 2.2046 pounds is equal to 1 kilogram. And that's our conversion factor that we need. So we want to plug these numbers in such a way that we will cancel out our units. And so this will allow us to cancel out pounds. And then we stick our 1 kilogram here. And so we can bring in our calculator, and mine needs to be turned on. And so I'm going to do 32.0 and then 2.2046 and divide that by it. And you can see here we get a really long number. And so we would say that this is equal to 14.5151047,809, and that would be kilograms. Of course, we know that we not use all of those digits. The calculator gives us a lot. We start off here with 3. Remember, because this is a conversion factor, we don't consider these. These are exact, and so we really can only have 3 digits in our final answer. And this is 1, 4, 5, so we can keep these guys. And then for the 5 to round it, we need to look at this next digit, because this is 1, 2, 3, or 4. This is a 1. We round down, and this would be 14.5 kilograms. All right, and so that's what we're thinking our answer is. So we also want to check. It's easy to miss a conversion factor, to flip where those are on whether it's up or down. And so we want to make sure that we work through those. And so we would find our answer, and we were doing question 77, and we were doing number F. And right there we have 14.5 kilograms. So that's exactly what we need. And so that is solutions. That's the way that we were able to practice. So a couple of things is that as we're working on this, again, We want to make sure that you're using the textbook. Again, whether it's the physical or online one, they have lots of problems with some of the answers, most of the answers in the back of the textbook. And that's a great way to practice. And then also remember that homework sets 1 and 2 are due soon. So the textbook will be a great resource. So we'll talk to you soon.